and I'll disconnect the phone.
Already
Okay, I got the phone disconnected.
Do you want to take a question from last week? We already have one for this week.
Okay.
You want to
Whatever you
take that
wanna
one?
do. Yeah.
Take Mark's. So people give it a couple more seconds, let it level off. Okay. Get more coming in. Nope, that's it. So good morning, everybody, to Paradoxes class. This is August 29th, 2021. And the Paradox class is the Hugh Ross's Sunday school class. Hugh Ross is an astrophysicist, and he's here to present and answer questions. So we're going to take the first 15 minutes to answer questions, and then Hugh will do his presentation. Then we'll wrap up with questions at the end. So Hugh, would you like to pray to start us out?
Yeah, let's do that. And let me introduce you too, because you didn't introduce yourself. Jamie Campbell, who's our co-host and will be handling the Q&A. Father in heaven, we thank you for this day that you've given us. Lord, every day that you give us here on earth is a gift, it's a blessing, and pray that we would honor you with that gift. Help us this day to receive more of your life, your love, and your truth. And help us, Lord, to encourage one another too, to learn more from you. In Jesus' name, amen.
Okay, Hugh, the first question will be from last week. It's Mark Durham asked, he's in Southern California. He asked, in regard to Earth's and Moon's early coupled magnetospheres, is this proposing that life was on Earth prior to 4 billion years ago? If so, how much prior?
Yeah, actually it is not. I mean, it's crucial that we have that coupled magnetosphere previous to 4 billion years ago. But previous to 4 billion years ago, the sun's particle radiation, its solar wind, its ultraviolet and X-ray radiation flaring activity was 100,000 times greater than it is right now. It subsides down to about 1,000 times greater by about 4 billion years ago. And once you get past 4 billion years ago, the Earth's magnetosphere is sufficient to protect life. Before that, it is not. It needs the coupling of the moon's magnetosphere, but it is such that conditions on Earth are not suitable for life previous to 4 billion years ago. Number one, the existence of liquid water and solid rocks is fleeting. There is evidence that there were brief episodes previous to 4 billion years ago where you got liquid water on the surface of the Earth and solid rocks. But we're talking ephemeral episodes. It's brief and only in certain regions. And that right away eliminates any origin of life or life-sustaining models. But likewise, we got radiation from the sun that would eliminate the possibility of life previous to 4 billion years ago. Some people have speculated that there could be life between 4 and 3.8 billion years ago for brief episodes only. But the main reason why you need that coupled magnetosphere previous to 4 billion years ago is that the particle radiation, the solar wind, is so intense that without that coupled magnetosphere, the solar radiation, wind, and the particles literally would erode away all Earth's atmosphere and all Earth's surface water, which would eliminate life permanently on the Earth. And the Earth's magnetosphere by itself at that time was not strong enough to prevent the sun from eroding away all of our atmosphere and all of our water. And so basically you need that coupled magnetosphere to ensure that the Earth retains its atmosphere and its surface liquid water so that there could be future life. And I got a blog coming out on this, basically making the point that there's a new discovery that basically tells us that the moon indeed did have an intrinsic magnetic field up until 4 billion years ago, but not thereafter. There's been a lot of speculation that maybe lunar rocks, because that's the problem. Some of the rocks that have been recovered by the Apollo astronauts that are only 1 billion years old show a strong magnetic field. And people have speculated that maybe the moon retained its magnetic field a lot longer than 4 billion years ago. The problem is that contradicts the theoretical models, which tell us that the liquid core of the interior of the moon would become completely solid long before 1 billion years ago, probably became solid by 4 billion years ago. And therefore, how do you explain these highly magnetic rocks on the surface of the moon? The new discovery is this, basically research showing that if you've got a sufficiently large asteroid or comet striking the moon, that will magnetize the rocks in the vicinity of the crater site. And that's what's interesting, is all these rocks that show high magnetization that measure to be relatively young, they're all found in the vicinity of collision sites, impact sites. But they have found lots of rocks that are not associated with impact sites that measure 500 million years old to 3.9 billion years old, no magnetic field. So basically affirms that indeed the moon had a magnetosphere until 4 billion years ago, but not thereafter. That'll come out, I think, in early October, that article.
Great, thank you. I'm gonna have Doug McComb ask a couple questions. I'm gonna cut him in front of Stephen. Stephen will get to your question for sure. But because we didn't do announcements, I didn't do any announcements. So Doug asks, please update us on our meeting together in person in West Covina or wherever. And also, can you invite Travis Campbell back when you're away?
Yeah.
We really like Travis.
I'm glad they like Travis, and my intent is that because I'm going to be traveling quite a bit in the future, and typically the way Paradoxes runs, I'm in person 2/3 to 3/4 of the Sundays, but when I'm not, I slot in a member of our scholar community, and we're now above 150 scholars in the Reasons to Believe scholar community. Really amazing people. I really want those of you who are part of the Paradoxes class to actually benefit from some of the teaching they have to offer. And it's going to be a lot easier to slot them in when we move to this later meeting time. As to the question of when we are going to meet in person, our plan was to launch in late July for in-person meetings, but then the Delta variant hit, and it's really not safe to have in-person meetings. Los Angeles County doesn't permit it. And so, and we're committed to abide by the Los Angeles County health regulations. And so once they say it's safe for us to meet in person, then we'll begin in-person meetings, and they'll be held at the Reasons to Believe headquarters in our conference center. And the church that is sponsoring the Paradoxes class, Christ Church's Sierra Madre, they're asking if we can move the class to 1 p.m. And the reason why is they're anticipating that the 9 o'clock service for the church is going to be packed out. And they're really wanting to encourage those of us that are part of the Paradoxes class to attend the 10:30 service, the 9 o'clock service. And that actually gives us time to move people from the church over to the Reasons to Believe headquarters. And incidentally, we really can't meet at the church anyway, because the room we're meeting in, they're going to tear it down and rebuild it. It's going to be fantastic once it's finished. But while they're doing the construction, we do need to move to an alternate location. And that's why we're going to move the class to the Reasons to Believe headquarters. Lots of parking there. It's less than a 20-minute drive from the church. And the church has graciously said, we can use their 2 vans to move people from the church over to the Reasons headquarters and to bring them back. And also we're anticipating of being able to serve lunch at the Reasons to Believe headquarters. So you can go from the church service straight to the class. We're going to be setting up tables. You'll be able to eat lunch while we're doing the class. We're going to have the usual treats there. So it's going to be a great time to be able to meet back in person. But for all of you that have been participating virtually, that feature is going to continue. We were doing that 2 years before the pandemic. We're going to continue that. So anyone in the world will be able to participate live with us. They'll be able to ask questions. It's going to be very similar to the experience you have right here. However, we're not going to move to that format or that time until things have improved on the health horizon. Right now, COVID is raging throughout the United States, so we're going to wait until the health situation improves. Because the last thing we want to do is have people get sick because we're meeting in person. And incidentally, what we've done at the Reasons to Believe headquarters is to install medical grade air purifiers. There are 3 of them, top brand medical purifiers, and they're designed to kill viruses and bacteria that exist in the room. And we've been using, we had a meeting there yesterday. It was a virtual meeting, but the air purifiers are quiet. You can't hear them, but they're designed to try to keep people healthy and safe there. And hey, I think it's going to be great to keep people from getting the common cold, because that's not going away anytime soon. So that's it for announcements. Back to you, Jamie.
Thank you. So we got pretty much time for one more question before you start. I think it's 10:42. Stephen Posta is asking, hummingbirds, Stephen Posta in Spring, Texas. Shout out to Spring, Texas. Hummingbirds are in abundance currently here in South Texas. I have heard that they are in violation of one or more laws of physics. For something of its relative mass, they can change direction at a relatively high speed, as well as stop on a dime and hover in place. Are they breaking any laws of physics? And if so, how do they do it?
Yeah, they're not breaking any laws of physics, but they come really, really close. And it's because of their small body size that they're able to do what they do. The other amazing thing about hummingbirds is the size of their brains relative to their body mass. And so they're quite intelligent in spite of the fact that they're so tiny. I mean, I think we got some articles on hummingbirds on our reasons.org website, and it basically demonstrates the principle that you see in Psalm 104, that God has created life on our planet in great abundance and great diversity, and to such an extent that no matter where you go on the surface of the earth, and even if you dig deep into the interior earth, you find God's creatures. They're everywhere in the greatest possible diversity, the greatest possible abundance. And one of the benefits of that is that we human beings have a huge treasure chest of biodeposits. The other thing I think you can see from Psalm 104 is not only does God create life in the greatest possible abundance and diversity, he does it for the greatest possible time. The idea that you could have an abundance of life on a planet for 3.8 billion years is nothing less than a miracle. And the fact that we humans come at the very end of that window means we have the benefit of the greatest possible treasure chest of biodeposits. It's been measured to be a minimum of 76 quadrillion tons. And it's because of that, we can launch global high technology civilization. It's because of that we're able to take the good news of salvation through Jesus Christ to all the people groups of the world in a short period of time rather than a long period of time. So hummingbirds are a great example of God creating life and the greatest possible diversity, because it's right at the edge of what the laws of physics will permit. You know, another example I shared a few weeks ago is redwood trees here in California. They're at the maximum height that the laws of physics will permit. And because of God creating the maximum height, literally dozens of other species of life benefit. Dinosaurs are another good example, a land animal at the greatest possible body mass for terrestrial creatures. So everywhere you look, you see God creating life in the greatest possible diversity. And I've got some web articles coming out basically making the point that, we're encouraged, especially in the Proverbs, to study the creatures that God has created. And one of the benefits of that is what I call bio-inspired engineering, where we can study these creatures and say, hey, these creatures do it better than we can do it. Let's copy their designs and see if we can improve our technology. And if you're wondering why we're getting such amazing capability out of drones, especially these miniature drones with cameras on them that we can take when we're on our vacations, it's because of hummingbirds. They basically have copied the designs in hummingbirds and figured a way to make superior drones and to make them at low cost.
Excellent. Thank you. It's 10:46. Do you want to start?
Yeah, we'll start because we got a
presentation?
lot of interesting material I want to present. So with that, I'm going to share the screen and we'll begin the teaching time. And I'm going to teach for about 35 minutes and then we'll have another time for Q&A. And then we're going to have a web meeting time where everybody can turn on their cameras, microphones, and we can try to have some virtual fellowship with one another. And I got a virtual assignment for us too. So let me begin this. Okay, all of you should be seeing my first slide now. I show this slide every Sunday. It's just a reminder, if you don't get to ask your question in the Paradoxes class, I do take questions on Facebook and Twitter. And hey, if you want to post questions to our biochemist, Fuzz Rana, or Jeff Zwirink, or to Ken Samples, likewise, they have a Facebook and Twitter page where they take questions. And I actually have, people keep asking me, Hugh, do you have a frequently asked questions page? I do. It's at reasons.org. If you simply put into the search engine questions from social media or go to explore, you'll find it. And I've got posted about 101 page answers to the most frequently asked questions. And I'm on my way to building that up to a database of 1,000 answers to the most frequently asked questions. The database is on my computer, but I go through editorial team, we clean it up, then we post it. Every Friday, I post another answer that's been sent to me on social media. So yeah, if you want to look at the Q&A page, that's where you can go. And of course, we have a 24/7 YouTube channel that you're welcome to visit. And you can subscribe for free and they'll notify you of all the new videos that we're posting there on that site. And you can now get free chapters, I think, of all my books. I think they've just upgraded it where you can get a free chapter of any one of my books by going to reasons.org/Ross. So you can take advantage of that. This is the most recent book I've written on dual revelation, More Than a Theory, but I'm going to be doing an update on that. It's really not so much an update. It's going to be completely different and new book. And it'll be on dual revelation, the subject of the class we've been engaging for the past several weeks. And this is a docudrama we have on that subject. And what you see here is the URL you're going to need to get into our web meeting. You know, last Sunday, we had quite an interesting web meeting. Evidently, and Jeanette Roberts really got you guys fired up and gals on vaccines and COVID and viruses. And so we had quite an engaging time last week just in our Zoom meeting, dealing with all these different questions. Incidentally, it caused me to do a lot of research. So during this past week, thanks to the questions you've been raising, issues you've been raising, I've actually done a lot more background research. I'll be happy to report on that during the Q&A time or during our web meeting. But one of the things I'd like to do in the web meetings is for us to role play opportunities that God gives us to share our faith with other people. And so I like the web meeting because we can turn on our cameras and our microphones, we can engage one another, find out things about one another. But when we get into our role play exercise, It's going to be a chance meeting between someone who takes the role of a Christian, someone who takes the role of someone who's not yet a Christian, and a conversation gets started. And the non-Christian basically says, hey, how did you become a Christian? So the role play is within a couple of minutes to be able to briefly share your story of how you came to faith in Jesus Christ. And the rest of us are going to play the roles of bystanders. I can't tell you how many times I've been engaging a non-Christian on a spiritual conversation, and other people start listening in and they begin to ask questions. And often the bystander conversations actually take on greater significance than the conversation that originally got started. But I just finished writing an article. It's going to come out in October sometime on a new breakthrough by astronomers to measure what they call the cosmic dawn. If you haven't heard of that term, the cosmic dawn refers to the moment in the history of the universe when the first stars form. And that's kind of the big unanswered question in the Big Bang cosmology. Matter of fact, atheists that are opposed to the Big Bang creation model, and likewise people in the church like young earth creationists who see Big Bang cosmology as a threat to their creation interpretation, they will actually cite the failure of astronomers to be able to see the first stars in the history of the universe as a problem for the Big Bang creation model. Well, it's not so much of a problem as a technology issue. We presently do not have the technology to be able to see the firstborn stars. They're just too faint for our telescopes to pick up. And for that reason, back in, a quarter of a century ago, there was a big movement by a group of nations saying, we need to build a telescope powerful enough so we can see the first stars in the universe, determine when they form, determine what these first stars are like. Because there's a variety of different Big Bang creation models that predict different features for these firstborn stars. So it'd be wonderful if we could actually not only see the firstborn stars, but measure their characteristic features. And that therefore we could develop a more detailed Big Bang creation model. And also it'd be great to actually see how do galaxies form and what do the firstborn galaxies look like? What are their characteristic features? And this is the reason why back in the mid 1990s, the NASA and the European Space Agency and the Canadian Space Agency got together and said, let's build a telescope with the power. And that was the birth of the James Webb Space Telescope project. And this next slide actually shows you the status of the James Webb Telescope as of a few days ago. I actually got to see this telescope in person. It's a lot of its construction and testing has been done at Northrop Grumman, which is a good 50-minute drive from where I live. It's in Torrance, one of the suburbs of the Los Angeles basin. And because I knew an engineer that worked there, he says, hey, I can bring you in on the weekend and you get to see this thing. It's been totally off limits to the public, but he was able to bring me in. I was able to get a close-up view of this incredible telescope. But this photo here shows you the status of the James Webb Telescope as of a few days ago. It's still there at Northrop Grumman, but it's being prepared to be transported for launch. It's going to be launched from South America and French Guiana, and they're going to use a European Ariane rocket to launch this into the location and where it began its observations. I didn't get to see it like it is right here. Here it is all folded up, ready to be put into a spacecraft, but I got to see it when the solar shields were laid down, and I actually could see the details of the mirror in the secondary. But as you can see here, it's designed in such a way that the mirror actually folds. And so you get to see the three of the panels of the telescope mirror folded off. to the right, and likewise, you got some folded off to the left. If you look at the very top, you can see the secondary mirror, and then you can see the arms. So it's all designed so that it can fold out like this. And so, yeah, it's being shipped right now to its launch site. And the launch date was scheduled as October 31st, but they've now moved it to sometime in November. The latest launch will be the first week of December. So it's quite confident now that it's actually going to get launched. But the big job right now is getting it safely transported through the Panama Canal into French Guiana and installed inside the Ariane rocket launch. And this next slide actually shows you what it will look like. And incidentally, this was started by the Canadian Space Agency, the European Space Agency, and NASA back in 1996. And back then, they projected it would take 10 years before it could be launched into space and was going to cost $500 million. It became a 25-year project, and the price went from $500 million up to $10 billion. So it's become a whole lot more expensive than people thought. And it was actually thought of saying, hey, 10 billion is way too much money. We need to just cut our losses and abandon it. But the problem was so much engineering and science went into this that they said, no, it's too big to fail. We need to finish this. Well, it is finished. And it's been at Northrop Grumman, they did 2 years of testing because one of the problems is it's not going to be like the Hubble Space Telescope. They're not going to put it in Earth orbit. This telescope is designed to actually look at the cosmic dawn, to see the first galaxies, to see the first stars, to measure their characteristics. It's also designed to be able to detect hundreds of thousands of planets orbiting other stars. And that's why the design team realized we need to make sure it operates not only at visible wavelengths, but also at infrared wavelengths. Because when you're looking very far away to where the first stars are, then you're looking like 13 billion light years away and more. These objects are highly redshifted. So they're not, the bright spectral lines are not going to be visible in the visible part of the spectrum. They'll be in the infrared part. So that was one of the big design features, is that it had to be able to operate at infrared wavelengths. And also they wanted to be able to operate without having any coolant. And so this is why they had it designed with these solar shields. You can see at the bottom that you got these 5 panels of shielding, and then there's a shielding underneath that as well. And this is designed to permanently shield the James Webb Space Telescope from solar radiation and also Earth radiation. Because that solar radiation, Earth radiation, will generate enough heat to make infrared observations impossible. And so they need to set it up in such a way that it's permanently shielded from the heat being radiated off from the Earth and also from the sun, which meant they couldn't put it in Earth orbit. And so they're actually going to send it out to what's called one of the Lagrange points. Is going to be the L2 Lagrange point in the Earth-Sun system. So it's basically going to be positioned 1.4 million kilometers away, about 930,000 miles away from the Earth. Is going to be put at a point where it'll share the orbit of the Earth around the sun, but it'll be a place in the orbit about the Earth about the sun where it'll suffer almost no perturbations. And so it'll be in a stable position relative to the Earth, which means they can permanently ensure by positioning the telescope that it'll experience no heat from either the sun or the Earth 24/7, 365 days of the year, which means they don't have to put any coolant into the system. And the problem with coolant is it's temporary. The coolant base over time evaporates, then you don't have any. That was the problem with the Planck satellite. the liquid helium coolant they put there to make the Planck satellite operate to measure the cosmic background radiation, aka the radiation left over from the cosmic creation event. Once that liquid helium had got completely evaporated, that was the end of its observational service. And so they said, look, given all the money we're spending on this James Webb Space Telescope, we need for it to be able to operate without any coolant at all. And so that's why they have to have this very sophisticated shielding system. And you might say, well, why these 5 layers? Well, what they already know that these layers are going to be punctured by meteorites, by meteoroids in the interstellar space. And so by having 5 of these shields, the goal is that even with holes punctured into this shield, it'll still provide adequate cooling. So you say, well, how big is this thing? Well, I think you could tell from the previous slide. I can go back to this previous slide. You can get some idea of its size by looking at the men in clean suits at the bottom. So yeah, it's quite a large telescope. But if you were to compare it with the Hubble Space Telescope, the diameter of the mirror is 6.5 meters or 256 inches. The Hubble Space Telescope was 2.4 meters or 94 inches. This telescope will have 7 1/3 times more light gathering power than the Hubble Space Telescope. So it's significantly more powerful than the Hubble Space Telescope. And the Hubble Space Telescope couldn't operate very far into the infrared just because of its experiencing too much heat from the Earth and from the sun. This will be able to go quite far into the infrared. And that's where these distant stars and galaxies are going to be brightest. You say, well, how does this thing compare with the largest ground-based telescope? The Keck telescope, which is currently the largest of the ground-based telescopes, is 400 inches, but there are 2 of them. So it's 2 telescopes, both 400 inches in diameter. This will be smaller than that, but because it's in outer space, it's going to have much higher resolution than a ground-based telescope. There'll be no atmosphere to disturb the quality of the observation. So they'll actually go to the theoretical resolving limit, and it's going to be able to make observations. In fact, this will be the only telescope that's going to be able to make high sensitivity observations in the infrared part of the spectrum. No ground-based telescopes able to do that. There is one telescope orbiting the Earth that is able to observe in the infrared thanks to using a coolant, but this is going to be able to do it long after the coolant in that particular space telescope is able to operate. And this next slide kind of shows you how the sun shield works, the sun/Earth shield works, and it actually shows you all the panels, solar panels that are in place to get electricity from the solar radiation. And you can see the antenna there, which is going to beam information back to the Earth. I was a little disturbed when I visited Northrop Grumman that there's only one antenna, because there's been incidences where the antenna that sends information back to Earth has failed. And then what do you do? But I've been assured that they've exhaustively tested this thing, and they said, we're confident that it will not fail and it'll be able to permanently send back information to the Earth. And part of the problem is the weight. They had to make this telescope lightweight. And notice it's way bigger than the Hubble Space Telescope, but it weighs only half as much as the Hubble Space Telescope. So that's why they went to a lot. In fact, a lot of the costs in designing this thing and building this thing was to keep the weight down. And so they said, hey, we had to just do it with one antenna because it's a fairly heavy part, and they wanted to keep this thing as light as possible. And keep in mind too that with the Hubble Space Telescope, they're able to put it in a space shuttle with astronauts. the astronauts were able to help get it positioned into its right place. Because they're sending this out to the Lagrange point, where it's going to be possible to do these infrared observations, it's not going to be possible to have a repair mission. It's not going to be possible to have astronauts actually help get this thing set up. It's all got to be done automatically. And so when I was at Northrop Grumman, I got to see exactly how they designed this thing so that it actually fits inside a rocket and can get to where it needs to be. And then it gets ejected from the rocket and automatically unfolds into all of its configurations. So this next slide actually shows you how it's going to be housed in the Ariane rocket. And it's already configured for its fitting into the rocket. But this is what it's going to look like. This is the top stage of the rocket. So it's all going to be able to fit inside there. But what I think is one of the amazing engineering marvels of this space telescope is what happens once it gets to the Lagrange point. The rocket will automatically eject this James Webb Space Telescope. And then over the course of several minutes, it's gradually going to automatically unfold and take its configuration. If you want to actually see how this is going to work, NASA has actually created a 5-minute video clip that you can watch on YouTube. And this is the video address you're going to need. And if you actually go to the NASA website and put in James Webb Space Telescope, you'll see they got lots of short videos of the James Webb Space Telescope. The longest one's a little more than 5 minutes. That's the one I think you're going to want to see. I watched it. It's utterly amazing how this thing is designed. It's all kind of folded up. And once it gets into place, the solar shield comes down first, step by step. And then you actually see the secondary mirror fold out and snap into place. All the equipment is put into place. The mirror is all folded up, it unfolds, and you get the complete mirror. All this is happening automatically from signals here from Earth. But yeah, one of the reasons why they exhaustively tested this thing for more than 2 years, this thing has to work. There cannot be any failures. With the Hubble Space Telescope, as you're probably aware, there was a failure, and they were able to send up a team of astronauts to fix it. They're also able to send up teams of astronauts to do equipment upgrades. That's not going to be the case. At the Lagrange point, it's not possible to get astronauts out there to do a repair mission. And it's not even feasible with current technology to send a spaceship up there to do it automatically without astronauts. So the bottom line, astronomers said, look, given all the money we're putting into this thing, it's got to work flawlessly. It must be fail-proof. And so this is one reason why it went through much exhausting testing. But I can tell you this, this is such a sophisticated and complex instrument. There's no guarantee that it's all going to work perfectly without failure. After all, we got that Bible verse in John 17. In this world, you'll have tribulation, but take heart, I've overcome the world. As long as we're in this universe with gravity and thermodynamics, electromagnetism, things will go wrong, things will fail. Murphy's Law operates. I like to paraphrase that John 17:33. In this world, you'll have thermodynamics. In this world, things will go wrong. And it's for that reason, a team of astronomers said, you know, who knows if there's going to be future delays with this Hubble James Webb Space Telescope. Who knows how much time is going to be needed to get things set up and operating before we can do actual measurements using this telescope to see the firstborn stars in the firstborn galaxies. Let's see what we can do with the best telescopes we have available right now. So that's what I'm going to briefly report on, and we'll jump into our message on dual revelation. The latest effort to measure the cosmic dawn, as I mentioned before, is defined as that moment in cosmic history when the first stars and galaxies form. And what you see in the background and it's an artist's attempt to kind of show what the universe looks like when the first stars turn on. Our best cosmic creation models, Big Bang creation models, tell us the first stars very likely will be very massive. They'll form quickly, they'll burn up quickly, and they will die quickly. And it's because of that that we've not been able to see these firstborn stars, because they don't exist for a very long period of time, which means the only way you're going to see them is be able to look 13.5 billion light years away, because of the fact that the models tell us they're likely quite massive stars. And this next slide is another artist's depiction of what they think these first stars will look like. They're going to form out of condensing molecular hydrogen gas, and therefore they're likely will form in some kind of cloud of this hydrogen gas. And they're going to be big stars. And when they're forming, they're going to be very bright, and they'll be illuminating the hydrogen gas around them. So, but who knows until we actually can get our telescopes focused to see these first stars. And the Big Bang creation model tells us that you got the Big Bang creation event down to the lower left. And, as the universe expands from the cosmic creation event, you have this ionization, which means everything looks the same brightness. But when the first atoms form, this is the time when astronomers, for the first time in the history of the universe, can actually see some detail in the universe. And this is these maps of the cosmic microwave background radiation, where you get to see the hot parts of the universe contrasted with the colder parts. The temperature differences are only about a 10 thousandths to 100 thousandths of a degree centigrade. So very subtle changes. But we recognize that the hot spots in the cosmic microwave background radiation become future galaxy clusters, and the cold spots become the voids. And this happens when the universe is about 375 to 380,000 years old. But once atoms form, you get what's called the dark ages, where the universe goes dark. When all the atoms are ionized, this is when you got light everywhere in the universe. But as soon as atoms form, as soon as all those protons, neutrons, and electrons begin to come together and make atoms, then the universe goes dark. The cosmic dawn is when you get the first stars forming, and now you begin to see light again. So there's this episode between the formation of the first atoms and the formation of the first stars when the universe goes dark. And, the Big Bang creation model gives us a hint when we expect these first stars to form, somewhere around 250 million years after the cosmic creation event, according to our best Big Bang creation models as we anticipate it. But different Big Bang models predict different dates. And so it'd be really good to be able to actually determine an accurate date. And so one way to do that is to detect the most distant galaxies. As you look for galaxies farther and farther away, and so that's been a quest of astronomers literally for the past 50 years, is to use our best telescopes to try to look. And so it's actually been a competition among astronomers. Who can find the most distant galaxy? Because the most distant galaxy will be the galaxy in which the first formed stars in the universe are forming. However, in order to detect that galaxy, you need a whole lot of stars. You need billions of stars. So detecting the galaxy and dating when that galaxy formed does not give you the date for when the first stars form. It simply gives you the date when enough stars form that you can actually see the light of the galaxy. And so the mission's been, okay, can we actually extend our attempt to find these distant galaxies? And if you've got super sensitive telescopes, the most distant galaxies are going to get you a lot closer to the moment when the first stars form. Well, this is the latest attempts to try to measure the date of the forming of the first stars. when you make detailed maps, and the Planck satellite gives us the most detailed map of the radiation left over from the cosmic creation event, it tells us that the start of the cosmic dark ages begins 380,000 years after the cosmic creation event. I abbreviate it to CCE. And at that date, using the parameters that you can discern for the Big Bang from this map of the cosmic background radiation, actually gives you a rough estimate for the cosmic dawn. And what the Planck satellite team was able to publish is, based on our measurements of the cosmic microwave background radiation, the first stars cannot form any later than 650 million years after the cosmic creation event. And then the attempt was, well, let's look at these distant galaxies. This is the Hubble Ultra Deep Field, which is looking at galaxies 10 to 13 billion light years away. And what they were able to do is measure the ultraviolet photons produced by these very distant galaxies. And they've actually been able to find a galaxy at a redshift of 9.6. And that corresponds to 500 million years after the cosmic creation event. And which tells us that the first stars must have formed before that point. And so they kind of look at this most distant galaxy. This had the record until a few weeks ago. This was the record for the most distant galaxy ever found. And the fact that they were actually able to see the galaxy gave them, so, okay, there's already billions of stars in this galaxy. And so they're able to subtract off, saying, well, probably the first stars were forming about 200 million years before this galaxy that we can see at this distance. So that's one method. Another method is to actually look at the intergalactic medium. And we're able to measure X-ray wavelengths, the hot intergalactic medium, and realize that it must have been heated by starlight. And the indication is, it seems like it could have been heated by starlight as early as a redshift of 15, which corresponds to 260 million years after the cosmic creation event. But the error bar on that's about a plus or minus 100 million years. So the quest was, well, let's go back to these distant galaxies. And so a paper was published about 6 months ago. They looked at the Lyman alpha. That's the strongest spectral line that we can see being radiated by these distant galaxies. And they looked at this galaxy, MAC 1149-JD1. I mean, you got to love the names that astronomers attach to these distant galaxies. But they're able to accurately measure its redshift, and it has a redshift of 9.1. And so that gave an age estimate of about 290 million years for its dominant stars. And so they subtracted that off from the age that corresponds to Z equals 9.1, which gave them a rough estimate that the cosmic dawn occurred about 250 million years after the cosmic creation event. And what you're noticing is these independent measurements are all coming up around 250 million years after the cosmic creation event. Well, what's brand new is a team of astronomers said, look, this is all based on a single galaxy. What can we do to find more galaxies at this great distance? And this is at the very edge of telescope technology. So they said the only way we're going to get a sample size of more than one, where we can get an accurate measurement of the spectral lines in the galaxy, is to actually mobilize the most powerful galaxies all over the world. And so they did that, and over the course of a year, they were able to come up with a sample size, not of one galaxy, but 6 galaxies. 6 galaxies in the redshift range of about 8.9 to 9.3. And they pulled this off by getting telescope time on the European Very Large Telescope in South America, the Keck Twin telescopes that are operating in on Hawaii, the Gemini South Telescope, another large telescope in Chile, and then they use the Atacama Large Millimeter Ray. And so the Very Large Telescope, the Keck telescopes, the Gemini South Telescope, these are all telescopes that operate at visible wavelengths. The Atacama Large Millimeter Ray, it's a radio telescope operating around 1 millimeter wavelength, but it's actually an array of millimeter wave telescopes, and it ranks as the most powerful millimeter wave instrument in the world. So these are really the biggest and best telescopes, ground-based telescopes in the world. And by getting telescope time on all of them, they were able actually to get the database up to 6 galaxies at this very great redshift range. And the stars in these 6 galaxies were all measuring to be about 150 to 250 million years old, which implies a date for the cosmic dawn of 250 to 350 million years after the cosmic creation event. This actually ranks as the most accurate date we have right now for the cosmic dawn, somewhere between 250 and 350 million years ago. And some have argued, well, I think we can get it down to about 330 as the upper limit, but you still got a plus or minus 40 million years here. And that's the reason why astronomers are so excited about the James Webb Space Telescope. It's going to actually be able to give us an accurate date for the cosmic dawn, and not just an accurate date for the cosmic dawn, be able to tell us exactly what the first stars look like. You can find articles I've written at reasons.org where I talk about the range of models out there about what the first stars will look like. But they all wind up with significant features, additional features for the Big Bang creation model. You say, what's the theological significance of all of this? Well, as I've mentioned many times before, the Bible was the first written text to talk about Big Bang cosmology. It was the only text to talk about Big Bang cosmology until the 20th century. The Bible stood alone for thousands of years as being the only book that declared the universe has a beginning. A beginning includes the beginning of space and time itself, that the entire universe has been expanding from that cosmic beginning, how it expands under laws of physics that don't change, where one of those laws is a pervasive law of decay. In other words, a pervasive law of thermodynamics or a pervasive law of entropy. Hence, the Bible is implying we live in a universe that must get colder and colder in a highly predictable way as it gets older and older. And it wasn't until 1925 that astronomers had any clue that these biblical statements that the Bible had made were indeed correct. You'll find 2 articles on our website where I talk about the biblically predicted Big Bang creation model. One is one that I wrote with the partnership of John Ray, an Old Testament Hebrew scholar. He was the one that first pointed out to me that the words used for the expansion of the universe in different passages of the Old Testament are written using all 3 Hebrew verb forms of the verb natah, basically making the point, these are not figures of speech. These are texts that literally are declaring we live in a universe that continuously expands. And this is not just the hindsight of John Ray and myself. Jewish theologians writing hundreds of years ago, 800, 900 years ago, saw these same implications from the Old Testament. They too wrote about the beginning of the universe, the space-time beginning, the expansion of the universe, and the constancy of physics. So I got an article coming out on this in the middle of October. You can look for that. But I thought I'd give you an update right now. I actually have exhausted almost all my time, but I am going to give me a few minutes if you could to get into accommodationism. One thing I've not yet shared with you about accommodationism is its origin. Now, you can go into the theological literature and you'll see this term used as accommodationism for different theological points. Actually, goes back centuries. But is what is new. What we're really focusing on in this class is how accommodationism is being defined by conservative theologians who think that we've made a mistake on adopting the doctrine of dual revelation, that God, in a trustworthy, reliable way, has revealed himself through two books, the book of nature and the book of scripture, where the two books corroborate one another. Now, to be fair, these theologians are arguing that God indeed has revealed himself through two books, but not in a matter that they corroborate one another. It's actually a Christian feature of separate magisteria. It was Stephen Jay Gould, the atheist, who basically said there's no conflict between belief in God and what we see in biological evolution, because science and faith never overlap. Science and the Bible never overlap. They're separate magisteria. And so he's basically saying religion, Christianity, and the Bible, they deal with matters of faith and doctrine. They deal with matters of how we feel about our existence and about God. Science, on the other hand, deals with facts. It deals with the physical facts. And that got a reaction from Christians because it's like saying, hey, Stephen Jay Gould, you're basically saying science is trustworthy. It gives us the truth. It gives us the facts. Religion, the Bible, and Christianity, that basically gives us what makes us feel good. It's wishful thinking. But this goes back to Kenton Sparks. And this is the definition he came up with back in 2008 in his book, God's Words in Human Words. And he was one of the two theologians that were part of the launch of the organization BioLogos. He's no longer with them, but Kenton Sparks and Peter Enns are really the two theologians that launched this new perspective, this new teaching, this new doctrine of accommodationism as it applies to dual revelation. And so this is the original definition, and it's one of the more complete definitions. Accommodationism is God's adoption in inscripturation, and that's a term that implies the forming of the Bible, the forming of Scripture. Accommodationism is God's adoption and inscripturation of the human audience's finite and fallen perspective. Its underlying conceptual assumption is that in many cases, God does not correct our mistaken human viewpoints, but merely assumes them in order to communicate with us. So this is kind of the heart of accommodationism, that God partners with the human authors of these different books of the Bible and basically tolerates their mistaken notions about the natural world in order to make a more important theological point. Of course, this raises the issue: how do we determine when the human author is speaking and when the Holy Spirit is speaking? How do we interpret what is applying to nature and what is not applying to nature? And here's some additional quotes I'll give you, and then we'll move into our Q&A time. And this is something we're going to need to respond to. But that John Walton and the theologian Brent Sandy have written a book to complement the Lost World of Genesis 1. It's called The Lost World of a Scripture. It was written many years after The Lost World of Genesis 1. But it kind of follows up on the theme of what you see in The Lost World of Genesis 1, namely that the people that were surrounding the ancient Israelites in Egypt and in the Exodus and in the land of Israel basically didn't care much about nature at all. And this is a direct quote: people in the ancient world are aware of the material world, but they do not care as much about it as us, and they don't prioritize exploration of it. So it's basically looking at the ancient Near Eastern culture and saying, we don't find any evidence that they're interested in exploring the natural world or had any real care about it. They're certainly aware there was a material world, but that was the limit of their exploration. And I'll spend some time refuting that. It's like I kind of read this book and say, well, what ancient literature are Walton and Brent Sandy reading? Because I've read a lot of this ancient Near Eastern literature. I'm a scientist, they are not. As a scientist, I took courses in actually looking at what the ancients had written about science, and I'll be sharing with you the different perspective. But this is another statement that I found quite disconcerting, and that is that to the ancients, geology, hydrology, and chemistry were unknown. And it's like, haven't they read about Archimedes' principle? And if you look at the ancient Near East, whether you're in Mesopotamia or in Egypt, irrigation was taking place. You had these civilizations existing because they found a way to get the water out of the Euphrates and the Tigris and the Nile into their agricultural fields. And this required pumping water out of the rivers and distributing to their agricultural fields. And that's what hydrology is all about. Hydrology, geology are all needed in order to be able to undergo the extensive agricultural enterprises they were involved in. And that's indisputable. The fact that the ancients were already engaged in intensive cultivation through the principles of geology and hydrology. And this is going to have a factor in refuting this idea that the ancients believed in a flat earth sitting on an ocean where there's a dome over the flat earth and there's this huge reservoir of water over the flat earth. Since the ancients understood Archimedes' principle, they recognized that it'd be impossible for there to be a large body of liquid water above a solid or metal dome above the earth. There's no way you can get water up there. They understood the law of gravity, and there was a limit to how high you could pump water up. I mean, that's also something you see in trees. There's a reason why trees have a certain height, is because there's a limit to the degree to which trees can pump water above the surface of the earth. And the ultimate limit is 380 feet. And that requires very tiny capillary motion to get water up to 380 feet. When you're irrigating a field, you're using much larger conduits. And there we're talking just a few feet, maybe 10 or 15 feet, but that's the limit for getting water up. So we'll be talking about that next week, but I've gone way over time. So let me stop the share feature and we'll go back to some Q&A. I think you can tell that we astronomers are quite excited about the potential of the James Webb Telescope. It's really the only possible instrument that's going to be able to answer these big cosmic creation questions. I'll take questions on that. I'll take questions on what's going on with the dual revelation. And next week, I'm going to really dig in. Probably what I'll do next week, we'll have no discussion on a scientific discovery. We really need to make headway in trying to complete our series on dual revelation. And so in order to make headway, I might alternate the weeks where I talk about a scientific discovery and where we can actually dive deep into our study on dual revelation. But I'll take questions on any topic you want to raise.
Right. Okay, Hugh. Mark Durham from Southern California asked a question about the Watcher Angels. It says, how could the Watcher Angels that left their abode and mated with humans to produce the Nephilim, how could they manifest themselves to copulate?
Well, that's a big debate. There are Christian theologians who say the sons of God that had intercourse with the daughters of men that you see mentioned in Genesis 6:2-4 says they're not angels, because there's passages in the Bible that tell us the angels do not marry. So the idea that angels came to earth and married these daughters of men, that can't be true. But there's been pushback on that from other theologians that say, well, consider the text says that they do not marry. It does not say they cannot marry. And then you got that passage in Jude 6, which talks about fallen angels, demons, that left their estate, and how because they left their estate, God put them in a special prison house, the abyss. And you can tell from looking at the gospel accounts that when Jesus cast out demons from people, in each case they said to Jesus, "Do not send us to the abyss." Evidently, the abyss is a place the demons do not like. It's not a pleasant place for them to be. And but notice, in each case when Jesus cast out demons from people, he did not send them to the abyss. And what we see in Jude chapter 6, the abyss is a place for a particular category of demons that left their estate. And there's been debate about what that means, but the Greek phrase that you see there for left their estate would be consistent with demons that committed bestiality. Demons that violated the command of God, which basically said, do not sexually violate these human beings. And because they did that, they were sent to the abyss. Now, I want to be on record. That's one possible interpretation of those texts. Another possible interpretation is that they're demon-possessed men that went and had intercourse with these women. Another popular interpretation is that people speculate that God commanded the sons of Seth not to have intercourse with the daughters of Cain, and that there were sons of Seth that violated that command. I would argue that's probably the least probable of the three different interpretations, simply because if you actually take the texts that describe Goliath, who's identified as part of the Nephilim, and Og, the king of Bashan, who likewise is identified as being the part of Nephilim, is that it describes Goliath as being a height of 6 cubits and 1 hand, and which means even if you use the short measurements, he's a minimum of 9 feet 9 inches tall. And the physics of human beings is such that no human can attain that height. Now, the problem with us human beings is that our bone mass goes up geometrically with our height, which means that once you get past, say, about 7 feet tall, the weight of bones you have to carry begins to limit your mobility. And long before you hit 9 feet 9 inches, the loss of mobility will be total. And we actually see in Samuel that Goliath went into battle with a minimum of 250 pounds of armor and weapons. And a mere human would not be able to do that. So clearly there's something supernatural about the Nephilim. And in the case of Og, the king of Bashan, it tells us that he had to sleep on an iron bed. A wooden bed evidently would not be adequate to support his body. And it gives us the dimensions of his iron bed. Again, using the short cubit, it was 13 feet long and 6 feet wide. So evidently, he was a bigger individual than Goliath. Goliath was probably one of the smaller of the Nephilim. And we actually see that in the text. Whenever the Israelites encountered the Nephilim, they were terrified by the gigantic size of these creatures and their capability in battle. So on that basis, the Watchers, how could they actually impregnate women? The one thing I've seen too in the study of demons, yes, God has commanded them, do not sexually violate people, do not marry them. But the thing I've noticed in my exposures to fallen angels is that they're obsessed with sex. And lots of people who've studied demons to a far greater degree than I have come to the same conclusions. They seem obsessed with sex and obsessed with drawing humans into gross sexual immorality. And one of the symptoms I've seen of demon-possessed people, I particularly ran into this when I was in Russia during the Soviet era, is how quick they are to impugn vile sexual behavior to the person of Jesus Christ. And so that's the demon speaking, not the human speaking, in my opinion. So that helps, but if Mark's got a follow-up question, I'll be happy to take it.
Okay, we'll keep an eye open for a follow-up on. Steve Rogstad asks, what is your take on the science of the destruction of Sodom and Gomorrah and Lot's wife turning into a pillar of salt? What is your
Oh,
take on
yeah, what's my take on that? I think my short answer is I really don't know. It does say that fire and brimstone came out of heaven. So people speculate maybe there was a volcanic eruption. There's also evidence for tar sands at the south end of the Dead Sea, which is the most probable location for the 5 cities of the plain that they were situated, because it tells us that they were well watered. And that region just south of the Dead Sea does get a lot of runoff from the mountains around there. So that's why people think that's probably the best location for the cities. But that's also where you got some tar sands. And if they ignited, maybe that's how Sodom and Gomorrah were wiped out. Exactly how Lot's wife became a pillar of salt, I don't know. I don't know the chemistry of the salt. That doesn't tell us there. And exactly how that could happen. Hey, it's a miracle. God's got lots of different ways of performing miracles. But if anybody in the class has got some ideas, I'd be happy to hear it. But I think my best answer is I really don't know.
It's a good answer.
Okay.
Tonette Carroll has, it's kind of a long question here. And there's many parts to it, so you may have to split it up, but it's a good one, I think. Hello, he says, Hugh, my daughter sent me a video in which Professor Dave is rebutting a James Tour video about the origins of life. I shared with her one of your videos on the origins of life. She had a question about homochronality and abiogenesis. She says that it is common knowledge about how the building blocks of the building blocks were formed, but there are many different ways that the first life could have been formed. Professor Dave says that we don't know if homochronality was always a thing in the beginning. How do you respond? Also,
hey, tell you what, before you get to the also, because I'm not going to be able to remember all this, right. Let's do this one part at a time. Okay. Fazal Ron and I did attend the Origin of Life conference that was held by ISIL at the University of California, San Diego a few years back. And that conference highlighted the homochorality problem. And so there were several leading homochorality experts that spoke on this, and they basically talked about the success they were getting in the lab. And it's been well known for decades that if you want to get homochiral amino acids, and that's where most of the experiments have been done, because you're not going to get proteins unless all the amino acids are left-handed in their configuration. You can only connect them together if they all have the same configuration. They all have to be left-handed. But it's well known that the only possible naturalistic processes for getting homochorality are those that preferentially destroy the right-handed amino acids at a higher rate than the left-handed amino acids. And so what researchers did is they had controlled laboratory experiments where they were able to accelerate the destruction processes and see what they would get. But what I remember is that all the different research teams are saying, hey, in the lab, we've been getting up to close to 80% homochorality. But as we get to 80%, we discover we got no sample left. And basically what their studies showed, based on their experiments in the lab, that you're not going to get to 100%. So no matter how big a sample size you start with, by the time you get close to 100%, you got no sample left at all. Because again, you're having to destroy both the left-handed and the right-handed ones. And by long before you get to 100%, you've destroyed all of the left-handed and all of the right-handed. But they did say we can get close to 80% homochorality, but 80% still doesn't buy you an origin of life model. It's not going to work unless it's 100%. Now, There's been very limited experiments done on the other homochirality issue, and that is if you want to get DNA and RNA for those molecules to be constructed, the ribose sugars that connect the nucleobases, those ribose sugars all have to be right-handed. But there's not been very many experiments done on trying to get homochiral ribose. It's much easier to do the lab experiments on the amino acids than it is the ribose. So that's still an area of research that needs to be pursued. But you'll see a whole chapter on homochirality on our book, Origins of Life, where I talk about how if you want to do this outside the lab, there's really only two pathways that have been demonstrated to have any success at all. Actually, there's a third one, but the two would be maybe you could use, the ultraviolet circularly polarized light. That's the favored version. Circularly polarized ultraviolet light will destroy the right-handed amino acids more efficiently than left-handed amino acids. Then the other approach is to use the weak nuclear force as a way to preferentially destroy. That was abandoned decades ago because they're basically saying there's really no naturalistic scenario to set up the weak nuclear force as an efficient mechanism to drive homochirality. It's got to be circularly polarized ultraviolet light. But the only places in the universe where you got circularly polarized ultraviolet light at the necessary intensity are right next to black holes and neutron stars. Well, that's an environment where you're not going to get amino acids, period. The radiation there is catastrophic to amino acids, which is why we conclude in our book, Origins of Life, that there is no naturalistic pathway to drive homochirality. You're going to need to appeal to a divine miracle, or you could to appeal to brilliant chemists working in the lab. But that's what we heard at the Origin of Life conference. These are brilliant, well-funded biochemists using highly controlled environments in the lab. The best they could get was close to 80%. So someone that's a lot more brilliant and knowledgeable and more technologically equipped than those biochemists must have done it in the first place. So that's part one. What's part two? Okay, you're muted, Jamie.
Yep. Okay, so also my daughter asked about the amino acid found in a meteor. How did it get there?
Okay,
And
good
lastly,
question.
yeah.
Okay, I didn't mention the third possibility because they've actually discovered a tiny amount of homochirality in the amino acids that you see in meteorites. And we're talking like, 56% versus 44%. So you don't get much homochirality, but there's now evidence that when a meteoroid goes through our atmosphere and heats up and collides with the Earth, those heating events, either going through the atmosphere or being heated up when it collides with the Earth, that will drive a tiny amount of homochirality. But then there's the issue. What about the amino acids inside the meteorite? Where did they come from? Well, they've been exhaustively testing meteorites all over the Earth. And of the 20 bioactive amino acids, they have found 6 inside meteorites. But they're all at very low abundance levels, a few parts per million. And they're dominated by the simplest amino acid, namely glycine. Glycine's only got 10 atoms in it. So it's a rather simple molecule, and that's what dominates. And it's at a low abundance level. And, I've written in Origins of Life that the one place where these amino acids can be constructed is in dense interstellar molecular clouds. Those clouds are where we find the richest source of carbonaceous complex molecules. And as of last count, about 135 of these molecules have been discovered, all at a very low abundance level. But we also notice in these interstellar molecular clouds, you've got this cold chemistry operating where it constructs these molecules, but the same chemistry works to destroy those molecules. which explains why they exist at such a low abundance. And as of today, astronomers have not yet been able to find a single amino acid in any of these interstellar molecular clouds. You say, how does that connect with meteoroids? Well, meteoroids come from these interstellar molecular clouds. That's their source. And so that's where they get their amino acids from. And we've yet to find a nucleobase in these interstellar molecular clouds. We've yet to find ribose in these interstellar molecular clouds. But I've been on public record. We will find them because our failure to find them is because our current technology can go down to about 1 part per 10 million. But in the last year and a half, there's been new technology developed by radio astronomers where they're actually able to make detections of these molecules down to 2 parts per billion. And there's a new generation of instruments that are going to be coming out probably in the next few months that are going to get down to 1 part per billion, or maybe even a 1/2 part per billion. So we got increased sensitivity. And we already know the chemistry in these interstellar molecular clouds is capable of making these molecules at about the 1 part per billion. So I think it's just a matter of time before we detect these molecules. 1 part per billion, because yes, they're being constructed at a rate greater than 1 part per billion, but they're being destroyed also at those rates. So the residual amount is going to be around a few parts per billion or less. But there's actually chemistry done in the lab that shows when a meteoroid with, say, 1 or 2 parts per billion of these amino acids goes through our atmosphere and then crashes into the Earth, that actually produces additional amino acids, but produces them at levels no more than a few parts per million, and only the simplest of the amino acids. So amino acids like tryptophan, for example, have never been found. And in order to have life, you need all 20 bioactive amino acids. And incidentally, there's more than just the 20 bioactive amino acids. There's more than 100 amino acids. And these other 80 plus amino acids, they get in the way. And when you look at these meteorites that have amino acids in them, the bioactive amino acids, they also have lots of the non-bioactive amino acids. And that too is a problem for the origin of life. They're going to mess up the assembly of the amino acids together. And I could add this, and maybe this is part 3 of our question. There have been research done in the lab where they say, okay, let's just take these amino acids that we collect. So they just grab amino acids from biological systems and say, let's try putting them together in the lab. And what they discovered is the only way you can assemble them is to assemble them on some kind of clay substrate. And yes, they've had remarkable success in the lab, but again, under highly controlled laboratory conditions. And they've approached into the low 40s of being able to link these things together. But what they've discovered in the process, the more amino acids you link together on the clay substrate, the harder it is to pull the assembly of amino acids off that mineral substrate. And once you get into the mid 40s, it becomes like a glue that you can't take them off. They become permanently stuck to the clay substrate and therefore are useless for the origin of life. And by the way, if you want proteins so that you can have a living system, you need to be able to make proteins with more than 10,000 amino acids. 40 is not going to do it. You got to get up to the 10,000 plus. And what I like about the videos being produced by Jim Tour, he and I are friends. I've spoken on his university campus several times. And Jim makes molecules for a living. He's a nanotechnologist. And basically, he's being able to communicate as a Christian to the community of origin of life biochemists. Look, I make molecules for a living. You make molecules for a living. We all know how extremely challenging it is to make molecules from scratch. To claim that nature, without any divine intervention, made these molecules from scratch is utterly absurd. Just look at how hard it is for us to do it in the lab. And Jim Tour is one of the world's leading nanotechnologists. He's probably at the top of his field in being able to construct these molecules in the lab. But the whole point is it takes someone a lot smarter than Jim Tour with a lot more funding behind him and a lot more knowledge to be able to pull off the origin of life in the first place. So, are any more parts to her question, or did that cover everything?
There are, but I've got a burning question from a 6-year-old.
Okay, let's go for that.
I want to get, so I'm going to ask Tonette to ask the last question next week. I've got it saved, and if I remember, I hope I'll be able to put that out there next week. And I'm sorry about that, but Esther McCorkle Hollis is asking, Olive, age 6, is wondering, how do stars light up?
How do stars light up? Great question. And incidentally, I asked that question of my parents when I was 8 years of age. So I'm really impressed that there's someone only 6 years of old who has that burning question. Sorry for the pun. Okay. Stars form as a result of gravitational collapse. And so you got these giant gas clouds, and we see them all over a galaxy and other galaxies. We call them dense interstellar molecular clouds. And if they get gravitationally disturbed, and they do because of adjoining stars, and also these interstellar molecular clouds bump into one another, you'll see that in parts of these clouds, gravity takes over and begins to collect this gaseous material and condense it. And so you got this collapsing gas cloud. And thermodynamics tells us any system that's undergoing collapse will heat up. And what you can share with your 6-year-old is that it's the same principle of your car engine. When the piston chamber compresses, the temperature goes up. When the piston chamber expands, the temperature goes down. That's how the automobile works, because when the piston chamber expands, the temperature goes down, the gasoline stops burning. But when it recompresses, then the gasoline will reignite. Well, it's the same principle with stars. Once gravity collects all that gas and the temperature goes up, and eventually it reaches a point where the temperature is high enough to ignite nuclear fission. Nuclear fission is ignited first, then nuclear fusion is ignited thereafter. And once nuclear fusion is ignited, you've got a stable burning star. You say, what's nuclear fusion? It's where the interior of the star, the core of the star, because of gravitational collapse, has reached a temperature of several billion degrees. And that high temperature is enough to force the hydrogen in the core of that star to come, the hydrogen atoms will come close enough together that they'll fuse and make helium. And hydrogen fusing to make helium releases nuclear energy. And so our star, the sun, the light and heat you see from the sun is coming as a result of the ongoing fusion of hydrogen into helium. Or you can think of it as a gigantic, continuously exploding hydrogen bomb. That's a good description of our star, the sun. Matter of fact, back in 1938, astronomers studied our sun, figured out how hydrogen was fused into helium, and how the sun was able to shine consequently for so many billions of years, and said, hey, we can use that same physics to make a bomb. And so it was research on the physics of the sun that eventually led to the invention of the hydrogen bomb. And that's where you kind of do the same thing. You compress the hydrogen to such a great degree that it fuses to make helium. But in the case of a hydrogen bomb, it's not continuous because you can only sustain the compression for a fleeting second. So you get one ignition and that's it. But because the sun is so incredibly massive, it can sustain the hydrogen bomb fusion mechanism continuously for 9 billion years. And yeah, you can tell your 6-year-old that the sun's been doing that for the past 4.5 billion years. It's gone through half of its nuclear fuel. And so another 4.5 billion years, it's going to run out of fuel. And when it does, it's going to greatly expand because no longer is there the heat, pushing out and and it'll actually, again, following that, contract and become a white dwarf. A white dwarf is a dying star. If you want an analogy you can share with your 6-year-old, dead stars or dying stars, white dwarf stars, are kind of like an ember on an open fire. When you put wood on an open fire, the wood burns brightly, but once all the fuel is exhausted, all you got are these charred embers, and they're basically cooling off. You wait long enough, you can watch the color go from red to orange, or orange to red, then a dark red color, and then it becomes black. What we see with white dwarfs, they've not yet become cool enough to become orange or red. They're still white. And there are no black dwarfs. The universe is too young to have any completely burnt out stars. But we do see lots of stars that are cooling. About 20% of all the stars we observe are stars that have run out of nuclear fuel and are cooling as white dwarfs. Hopefully your 6-year-old will be able to actually comprehend all that. And you know what my parents told me, and I was asking questions about how stars burn and why they're bright and hot. They told me to go to the library. And that's when I was able to come back at 8 years of age and explain it all to them. So hopefully your 6-year-old will be able to explain it to you likewise.
All right. Thank you so much. And thank you for Tanet for understanding. It's 12:01, Hugh.
Okay, tell you what, I'll share feature again and give you the URL for our web meeting. And then we'll stop the webinar. And those of you who can join us can come with us into the web meeting. I've already announced it before, but let me put up the URL again so that you can see the address. Here we go. Okay, this is a URL you're going to need for the web meeting. And once you're in the web meeting, you'll be put into a waiting room. Give me a minute or two to pull all of you from the waiting room into the web meeting. Once you're in the web meeting, you can turn on your camera, your microphone. You can start engaging one another. It's a great place to get to know different members of the class. And once we all get introduced, we're going to go into our role play. And by the way, last week was just kind of a continued Q&A, particularly in viruses and what's going on with these treatments and vaccines. I'm happy to continue that discussion, but also I'm happy for us to go into our role play mode. Hey, it's a time where we can do whatever we want. And, you know, the big frustration of this web format for the Reasons class, we really don't have the kind of in-person fellowship that we have when we're meeting face-to-face. But this is the best we can do with virtual. And so we're going to end this right now. That's the URL you're going to need. It's the same URL we've been using for the past several months. So you've already got that recorded. You're good to go. But with that, let me stop the share feature here. Okay, and I'll end the webinar and I'll see you in the web meeting.